Good morning, everyone, or good afternoon, depending on when you're listening to this. Today we are going to look at the notes for section 5.2, which is all about friction. And we are going to start, as we always do, with a little bit of review. So a force is a push, pull, or twist. All right, this should be very familiar to you by now. Here's one from way back when. Forces can be contact, right, which means the two surfaces are touching each other, or they can be long range, like gravity, right? You don't have to be touching the earth for gravity to pull you down. A free body diagram shows all the forces acting on an object. And here is our practice free body diagram. Now also you should be pretty good at this by now. So we're going to look at pairs of forces. So we are going to look at our downward force, which of course we know is the force of gravity, Fg. We are going to look at our upward force, which is going to be equal and opposite, and now we know that's called normal force. We are going to look at a force going to the front. We know that that would be the pushing force, and we're going to look at an equal and opposite force going to the back, which is the friction force. Now, we've talked about friction, we've drawn that friction arrow, but we've never really figured out what causes friction, so that's what we're going to do today. What causes friction? So, if we look at our pairs of forces, we can see that we know that normal force is equal and opposite to gravitational force. And as long as this car is not accelerating, we can also say that the friction force is equal and opposite to the pushing force. All right, so do you see how those pairs work together? There's a horizontal pair, the pushing force and the friction force. There's a vertical pair, the normal force and the gravitational force. All right, so far so good. So what is friction? Well, friction is a contact force. So you don't have friction if you're not touching something else. So it's a contact force that opposes motion. What does that mean? So whichever way this car or other object is moving, friction will be the opposite way. So if I'm pushing the car to the left, friction will be to the right. If I'm pushing the car to the right, friction will be to the left. It always goes in the opposite direction that the object is moving. You know from watching the Edpuzzle video and doing your reading that there's static friction, which is friction between two, well, maybe I should spell that correctly, huh? Two stationary, not moving, objects. And there's also kinetic friction. And kinetic friction is between two moving objects. We are much more familiar with kinetic friction because we deal all the time with having to overcome the friction of something that's moving. So that's what we're going to focus on today. We're going to look at the kinetic friction between two moving objects. All right? So that's our goal for today. We are going to look at how friction forces are determined and how they oppose motion. All right. So friction changes. That probably makes sense to you if you stop and think about it a little bit, right? Friction's not the same all the time. So friction depends on the weight, or the normal force, of an object. So the heavier something is, the more friction there is. That probably makes sense to you. Heavier objects experience more friction. Okay, and it also depends on the type of surface. If you stop and think about that, that's going to make sense to you as well, right? So smoother surfaces have less friction. So think about, have you ever walked across a parking lot? And in the summer, if you walk across the parking lot, your shoes might even stick to the parking lot, right? It might be really, really sticky, and your shoes would stick, and it would be maybe hard to walk. The same parking lot, after it has snowed or we've had freezing rain or something like that, is going to be really slippery, right? And so the surface changes, and the amount of friction changes depending on what kind of surface it is. All right, so let's get down to the nitty-gritty here. How would we calculate friction? So if we want to know friction, we have the force of friction, right, F sub F, is equal to mu, that's a funky symbol, isn't it, times the normal force. And I just realized that I skipped a whole section up here. So let's talk about the coefficient of friction. The coefficient of friction takes into account those surfaces that we talked about earlier. So the coefficient of friction is this funky thing, mu. It's a Greek letter. Whether or not you know it's mu, I really don't have a preference for, but you need to know what it means. It means the coefficient of friction. And mu tells us how sticky or smooth a surface is. Okay? So if we have, like, cement or something, that's going to be more rough, more sticky than something like ice. Okay? And so the coefficient of friction lets us know that. The bigger the coefficient of friction, the more sticky something is. The smaller coefficient of friction, the smoother something is, the easier it will be to move. Okay, sorry I did that in the wrong order. Here we go. So now we have our formula for friction. Friction is equal to mu times the normal force. And if we rearrange that, then we get mu is equal to the friction force divided by the normal force, okay? So same formula, all we did was rearrange a little bit. And then there are a couple of formulas we're going to need that are review formulas, so let's go ahead and put them in here as well. We are going to need to be able to figure out the weight, so Fg equals mg, and we need to be able to figure out the normal force, and we know the normal force is equal and opposite to the weight. That is why we practice so much finding the normal force of things. All right? So here we go. Here is our first practice problem. A box of books is being pushed across a tile floor. If the mass of the books is 13 kilograms and the coefficient of friction is 0.05, how much friction force will be opposing the motion of the box? So we are going to start with our free body diagram here. So there's my dot. I'm going to draw my pairs of forces. I know that the gravitational force is down. I know that the friction force is up. I'm going to decide that we're pushing to the right. There's no person on this picture, so I can decide. And that means that the friction force will be equal and opposite to the left. Okay? So, let's see. The problem tells me the mass is 13 kilograms. The coefficient of friction, that's that mu thing, is 0.05. Oh, I almost forgot. Notice that there's no units on the coefficient of friction. That's weird, huh? I'm always about writing in the units. Well, there's no units for this one, so it's just going to be a number. And what am I looking for? I am looking for how much friction will be opposing the motion of the box. What else am I going to need to know here? Well, I'm also going to need to know that the normal force is equal and opposite to the gravitational force. All right? And so we need a strategy. So here's my friction force, mu times the normal force, okay? And I know mu, that's going to be 0.05, but I don't know the normal force. So here's my strategy. The first thing we're going to do is find the normal force, and then I can find the friction force, okay? So that's our strategy. So in order to find the normal force, I need to find the weight, and I know how to do that because weight is mg. So that was a bunch of steps, wasn't it? Let's go back and look at that again. So what I want to find is the friction force. In order to do that, I need to know what the normal force is. in order to find the normal force, I am going to have to find the weight, right? And then I can go back and find the friction force. All right, so there's our strategy. We're going to start with finding the weight. That will tell us the normal force, and then we can find the friction force. A lot of steps, isn't it? All right, luckily none of them are very hard. So I have got my 13 kilograms. I know that gravitational force, in this case, we're going to make it negative because we're going to say that down is the negative direction. And so this is going to give me negative 127 newtons. So there's step one. Now I know the normal force is equal and opposite. So my normal force is positive 127 newtons. Now that I know the normal force, I can take that, I can put it in here, and find the friction force. So my friction force is going to be mu, which in this case is 0.05, times, oh, I've forgotten, what was it? 127. And that means that my friction force is 6.4 newtons. If you want to be really correct, you can say that because of how I drew my picture, it would be 6.4 newtons to the left, but I won't be that picky. Okay? So I've gone through a lot of notes pretty quickly there. I want you to stop for just a minute. I want you to look back over everything. Do you know what friction is? Do you know which direction friction is? Do you know what the coefficient of friction means? And do you know how our strategy went to find all these things? So stop the recording, look back over your notes, make sure it makes sense to you. All right, good for you. And if you have any questions, make sure you write them down so that we can talk about them in class next time. All right, example number 2, box of books. I wasn't very creative on these notes, was I? Is being pushed across a carpeted floor. If the mass of the box of books is 55 kilograms, well, this box is much bigger, right? The pushing force is 19 newtons. What is the coefficient of friction? So let's go ahead and draw our free body diagram. There's my dot. I have the force of gravity going down. I have the normal force equal and opposite going up. I have, let's push it the other way this time. So that would be the friction force, and that would be the pushing force. Okay? And again, my pairs are opposite, right? Equal and opposite. So I know the normal force is equal and opposite to the gravitational force. I know the friction force is equal and opposite to the pushing force. Everybody good? Okay. So let's see. The problem tells me the mass is 55 kilograms and the pushing force is 19 newtons. All right, and we are looking for the coefficient of friction. So if I look back up here, here's my coefficient of friction formula. So I've got mu equals FF over Fn. All right, now we're going to need a strategy to do this as well, right? So before we can do anything, we need to know what the friction force is. We need to know what the normal force is. And what that means is that we're going to have to remember that the friction force is equal and opposite to the pushing force, and that the normal force is equal and opposite to the gravitational force. All right, so again, we have a strategy that we're going to have to do here. I can't jump right in and solve my problem because I don't actually know those things yet. I have a couple of steps to do first. So I need to find the friction force, I need to find the normal force, and then I will be able to find mu. Okay, so let's start with the friction force because I think that one's going to be the easiest. The friction force is equal and opposite to the pushing force. The problem tells me the pushing force is 19 newtons, so that means the friction force is negative 19 newtons. That wasn't too hard. All right, normal force. Normal force is equal and opposite to gravitational force. Gravitational force is m times g. So I know that my mass is 55 kilograms. I know that gravitational force is 9.8. Let's go ahead and make it positive this time just for fun. We'll say that down is the positive direction here. So I'm going to end up with 55 times 9.8. When I put that in my calculator, I get 539 newtons. And if my normal force is equal and opposite, then I have negative 539 newtons for my normal force. All right? And both of those steps were leading us to find the coefficient of friction. So now I can say the coefficient of friction is negative 19 over negative 539, which means that my coefficient of friction is 0.04. Remember, there's no units on this. All right, so that means that the carpet is must be a pretty slippery carpet, because 0.04 is a pretty small coefficient of friction. All right, so you have a couple of problems to try on your own. All right, 1 and 2 and 3. Please make sure that you draw your free body diagram, that you list out what you know, that you do those steps in order to get where you want to be, and that you show all your work. All right, and if you have questions, please make sure that you ask them in class next time. I will be happy to go over them with you. Thank you very much. I will see you next time.